We're still dealing with our linear equations here, but now we're going to start talking about rates of change. Okay, and you're going to find something that rates of change actually deal with things that we've already talked about. So this would be kind of nice. So first of all, inputs and outputs, that's, inputs relate to our x's, outputs relate to our y's. So let's fill out the rest of this table by using our linear equation on the right over here. So if I plug in negative 10 for x, that'd be y equals negative 3.5 times 10 plus 30. So I'd get negative 35 plus 30, which gives me negative 5. Okay, and then I'll do the same thing with negative 5. So y equals negative 3.5. Plug that in for x here plus 30. And I end up getting a positive 17.5 plus 30, which gives me, whoops, already made a mistake. I should have done a negative 10. So this should have been a positive 30. So that should have been a positive 65 right off the bat. Geez, check your work, huh, Mr. Etzel? There we go. Okay, so negative times a negative positive, so this should be 47.5. 0, well, if I plug in 0 up here, that's just 0 plus 30, so we get 30. That was kind of nice. And if I plug in 5, y equals negative 3.5 times 5 plus 30. So now we got negative 17.5 plus 30, which gives me 12.5. And if we notice, everything's starting. And lastly, plug in 10. So negative 3.5 times 10 plus 30 gives us negative 35 plus 30, which is a positive slash a negative 5. My fault. Negative 5. There we go. So we use that equation, fill that out. So now let's take a look and make some conclusions about what we just found. What is the change in the input? What's happening as we go this direction? It's going up what each time? Plus 5, right? So our change in the input is positive 5. How about for the output? What's happening here? Well, I kind of mentioned that in the last one. It looks like we're going down. Remember, I could just subtract. What would be an easy one to subtract? What about these two guys? 30 minus 12.5. It's going down 17.5 each time. There's the change in my output. Negative 17.5. Okay, well, let's think about this. Why is that not the same as our change in the equation? Shouldn't this change in the output match the change? Remember, it's y equals start plus change x. So the change should go with the x, right? Why do they not match up? The start is nice. Look at the start. The start one would be when x is 0, the start is 30. There we go. There's my start. I like that. Okay, but why are they not the same? It should be negative 3.5. Well, what do you think you need to do with these two numbers here? The change relates to how much it changes each time. So, for example, from 10, what does it do to 11? And then what does it do to 12? How does it jump up each time it goes up one in the x? So what should I do with these guys? We need to divide. We should take negative 17.5 divided by 5. So really, we're taking the change in the output and dividing it by the change in the input. So negative 17.5 divided by 5, that gives us negative 3.5. And that's where our change comes into play. We see that? So that should bring us to this. To find the rate of change, it's the ratio, which just means, ratio just means like writing it as division as a fraction. And the output values divided by the corresponding change in input values. So to find the rate of change, which on our graph, what we'll soon find out that this is the exact same thing as slope. You take the change of the output and divide by the change of the input. Or a way you can write that, we use triangles for the word change. That means like subtract. Find the change, how much it changes. So find the change in y divided by the change in x's. And if you notice, if we know things about slope, this is really your rise, right? The rise and the run, rise over run. That's our slope. So really when we talked about slope-intercept form previously, it's the same thing as our y equals start plus change x, correct? So this m, remember, represents our slope, and the b in this case represents our y-intercept. And we can also see it in intercept form. Remember, that's that y equals a plus bx. It's the same thing. Remember, the slope is just the number that's in front of the x. So that's the slope, or also know what we call the change. So we should be able to see the slope, the rate of change, the change, all kinds of words for the number that's in front of the x. The number that's by itself, that's our start, also known as the y-intercept on graphs. And it doesn't matter whether you put the x term first and then the b. So for example, like in this one, if I said y equals 2x plus 3, its change is 2, its start is 3, its slope is 2, its y-intercept is 3. If I just switch their spots, it's still the same thing. If I said 3 plus 2x, we still got the same. Slope is 2, the change is 2, and the start and the y-intercept would be 3. So just know, the number that's in front of the x is the slope. It's the change. It's the rate of change. You might even call it the ROC, the rate of change. Okay, so just understand that. The number that's in front of the x in your equations is always the rate of change, or the slope, or the change, or whatever you want to think of it as. Okay, so let's get a table here, and let's write a linear equation for this guy. So the start, how would I find the start? Well, what did we take a look at in that first example? Do I just pick this guy right here because that's where this table starts? No, the start is always when x is 0. So I need to find when x is 0. Okay, so let's hold that thought for just a couple seconds here. Let's maybe find the change first. So how do I find the change? Well, the change is the same thing as the rate of change, right? Or the slope. They're all the same thing. And how do we do that? Find the change in your output. It doesn't matter which two you grab. So let's say I want to grab these two. So I find out how much it changes. So I need to take that 23 and subtract the 14.2. Well, if I grab that for the change in my output, remember my change in my y, my change in my output, what two should I grab if I want to find the change in my x's, the change in my input? Can I grab like these two? No, I have to grab the ones that match up. So I better grab these two. Sometimes it won't affect it, but just be careful. And does it matter which order I subtract? Yes, it does. If I went 23 and then subtracted the 14.2, I better take 10 and then subtract the 6. They have to match up. And then we just go ahead and subtract, so I get 8.8 divided by 4. So our change would be 2.2. 2.2. Okay, so let's hold up. So I'm going to go back up. So remember, I can write it in y equals start plus change x, or I could write it in my y equals mx plus b. Remember, that just flip-flops the spots. Either way is just fine. So that's my change. So I might even put that. I'm going to put that right up here. Rate of change equals 2.2. So that guy's going to go in for the change. That's going to be in front of the x. Well, how do I find the start? So remember, the start is where x is 0. Well, a couple different ways to do this. We're not going to get too advanced yet, so hopefully you should be able to look at it and figure it out. So if I'm at negative 3.4, how many times should I add 2.2? Well, 1 would get me to negative 1, and I got to add it one more time to get to 0. Or I could think about it, I could add two 2.2s. I could really add just 4.4 off the bat. So I'm going to add 2.2 to negative 3.4, and then I'm going to add another 2.2. So I might even bust out my calculator and do that here. So I was at negative 3.4, right, when x is negative 2, and then I got to go up twice. And we're changing 2.2 each time, so I got to add 2.2 and another 2.2, or I could say 2 times 2.2, whatever you would like. Okay, I'm just going to do it this way since I'm only adding 2 of them. That puts me at 1. So when x is 0, y is 1. The output is 1. So that is my start. My start is 1. So that's going to go in for the start. So if I want to write it in that way, I would say y equals start plus change x. If I want to write it in slope-intercept form, I would just flip-flop their spots and say y equals mx plus b, so 2.2x plus 1. So either one of these is just fine. So this one says find the rate of change and write the equation in intercept form. So that's that y equals a plus bx, or what we've been using, y equals start plus change x. If you want to use y equals mx plus b, that's totally fine. Remember, it's just flip-flopping the spots, right? So these would be the same thing, okay? It does not matter. So let's take a look. So what do? To find the rate of change, you find out how much the y's change, right? The output in the y's, and then you find how much the change is in the x's. So what doesn't matter where you want to grab stuff from. So I'm just going to grab right here. So I like to always start from back and then move up. So I'm going to go negative 12 minus 6, minus negative 6, over, and then I got to do the same thing for the change in the x's. Since I started with negative 12 and went to negative 6, I got to go with 4 minus 1. And we subtract, so negative 12 plus 6 is really negative 6, and 4 minus 1 is 3. So I have a rate of change of negative 2. So I might even say ROC, rate of change equals negative 2, so I can see that. And then my equation would be, well, if I do it, y equals start change x plus change x, I'd say y equals, I don't know my start yet, but I know my change is 2. And how do I find my start? Well, my start is when x is 0. So when x is 0, it looks like I had to go back one, right? So I almost have to go back from negative 6. So this is kind of tricky. Well, let's just think of it the other way. If I went to 2, what would that be? Well, we're subtracting 2 each time, so this would be negative 8. If I went to 3, subtract 2, I'd be at negative 10. So if I went the other way, we'd be really adding 2, wouldn't we? So this would be negative 4. So there's my start. So my start would be negative 4. And if I wrote it in slope-intercept form, we just say y equals 2x minus 4. Either way is just fine. And lastly, let's just deal with this story problem here. So Holly has joined a video rental club. After paying $6 a year to join, she then has to pay only $125 for each new release she rents. Write an equation in intercept form or slope-intercept form. Either way, does not matter. If you want to use that, start plus change x or mx plus b, whatever you like, to represent Holly's costs for movie rentals. Well, let's see. If I go y equals start plus change x, what do we start at here? We start at $6 a year. So there's my start. So y equals 6 plus, and what are we changing? $1.25 for each new rental, each new release. So 1.25 times x. There's my equation. That's for A. So for B, it asks graph the situation for up to 60 movie rentals. Okay, so let's actually do that on our calculator. Let's go ahead and bust these out. So I'm going to go into my y equals, and I'm going to graph that. 6 plus 1.25 x. Graph. Did that show up to 60 movie rentals? I don't think so. Well, how would I change this? Okay, let's go into our window. This is how we adjust to see what it shows. So if we go to our window, if we take a look, this is what our x-axis shows. This is where the x starts, the minimum, and this is where the x ends, the maximum. And what does our x stand for? The number of movies, right? So if we want 60 movie rentals, can I have negative movie rentals? No. So let's start at 0, and I want to go for up to 60. So I'll go all the way up to 60. There we go. SCL means scale. So what do we want to count by? Well, should we count by ones? That'd be like 60 hash marks. Now let's count by tens. How about? That would look a little bit cleaner. Okay, and the same thing for y. Y is going to be the cost, correct? So y, we're not going to have a negative cost. Let's just start at 0. And how much could it cost? It starts at $6 a year and about $1, a little over $1 per movie. So let's maybe go to like $100. It's probably a good idea. And our scale, let's count by tens as well for that. XRES, don't worry about that. Let's just go ahead and graph. And to double check to make sure, to see where we're at, go ahead and click trace. When you click trace, it puts you right on the line. So here's my line. Start plus change x. And it tells me right now this is for 30 movies it would cost $43.50. So I could start hitting right and left and make some predictions. So for example, if I rented, about 46 movies, it would cost, about $63.50. So right here it says they charge $60 a year for unlimited movie rentals. How many movies would Holly have to rent for this to be a better deal? So $60 for unlimited movie rentals. So where is $60 at? Can I find that on my graph? Yeah, about right in here. So she'd have to rent how many movies? About 43 movies. So I could check this out right on my graph. Or what else could I do if I wanted to calculate it? What would I plug this 60 in for? Yeah, the total cost. So I'd go 60 equals 6 plus 1.25x, and I'd solve for x. So subtract that 6 over, and then divide by 1.25. So I get x equals, and let's see if we get the same thing here. So I'm guessing it should be about 43. So if I go back to my main screen and say 54 divided by 1.25, 43.2. So really, 43 rentals would be still good with this deal, right? 43 rentals. So I'd have to rent 44 for it to be a better deal. So 44 rentals. So 43 doesn't quite meet it, but 44 would make the unlimited much better. So just be careful when you're answering the question in the end.